My name is Sean Boulter. I'm an SE with Akamai, dealing exclusively in API security. So let's jump in here. A lot of this has to do with visibility, how APIs are attacked. Typically, when I go into an evaluation with the customer has about 10 times more APIs than they would ordinarily guess. And kind of regardless of what the number is, if we don't have a complete list of our APIs, it can be super challenging to figure out whether or not they are developed securely, whether they're following best practices, and that can lead to some interesting problems that we'll cover here in a second. So it all comes down to this old sort of adage that you can't protect what you can't see, and we'll show you what that means in a second. All right, so let me set the stage here on what we saw in a customer evaluation that we were doing. They were a major retailer. They were facing loyalty program hacks that just disappeared. Points were just disappearing from customers' accounts. There was a going theory that it was an internal job, that there were people inside the company that were actually stealing miles or rewards or whatever they were. So we were brought in to try and understand what was happening. So speaking of what you can't see, let's start with step one, with finding a vulnerable API. So what do we mean, first of all, by the word vulnerable? So in this context, vulnerable doesn't mean something that will respond poorly to like a SQL injection or a cross-site script or some kind of poison pill. In this case, it's vulnerable to abuse from a business logic standpoint. In other words, the attacker's looking for a bug in the API that allows them to do something that they're really not supposed to do. So how do they figure this out? There's automated tools like Burp Suite and Postman. Many of you probably used some of those. They're free. At least Postman is free. You can also right-click in your browser, and you can click on Developer Tools, you can click on Inspect, and you can see the API calls going back and forth between yourself and the application. You can also proxy traffic from your mobile app. Let's say it's a hotel, or it's an airline, or it's social media, whatever it is. You could use, let's say, Burp to proxy your phone traffic through Burp so you could see those API calls that your mobile phone is making. Basically, if you're using a modern application, there's API calls going back and forth. So what are they looking for? So this is where we've right-clicked on a web page and said inspect. This particular API, if you provide it a phone number, it will provide you with the customer or the person's home phone, street, state, postal code, email address, and their loyalty info. The thing is, this API wasn't authenticated, right? So the attacker just randomly, by a lot of trial and error, found an API with no authentication that would provide that information. So if he feeds it a home phone number, he gets all the rest of this stuff. So what does he have to do? All he's got to do is create a script, feed it with phone numbers, and harvest all of the loyalty information that's there, along with the email address and the home phone number. So now he knows which accounts have the most loyalty points. He knows their email address and knows their phone number, but what he doesn't know is how to log into their account, right? So his target account list is the people with the highest number of points. So what's he going to do? He's got two options: credential stuffing. So I know their email address, so I'm going to stuff passwords and try and get access that way. Or I could also call help desk and say, hey, I'm a customer. Could you please help me reset my password? Here's my phone number. Here's my street address. Here's my loyalty points number. And here's my email address. And he gets that reset, right? It's kind of game over now. He's got all of the loyalty numbers. He's got all of the email addresses. And he can just kind of slowly work through the process to exfiltrate actual points into his account, right? This wasn't SQL injection. This wasn't volumetric. This was simply being smart about what kind of API traffic he was actually seeing. So I have two more examples for you. Before we get to that, the resolution of this was very clear. Okay, here's an endpoint that needs authentication, right? It didn't have authentication. That led to the problem. That means that without authentication, he could just feed it a phone number and get back sensitive information. The other thing that was the solution is, if you remember, he took those email addresses and he started doing cred stuff. So the customer of ours added a multi-factor and they added capture to that login portal. So that took 2 steps to solve this. 2 more examples. So this is SiriusXM. You can go Google this if you want. SiriusXM had an authorization flaw where all of these car systems could be accessed by just knowing a VIN. How do you know a VIN number? You can look in the windshield, right? It's right there. With the VIN number, they could stop and start the car. They could honk the horn. They could turn on the air conditioning. They could do lots of different things. Even if you had registered your car with your manufacturer, there was an extra little problem with the login that allowed them to get access, even if it was protected by username and password. So this was not SQL injection. This was not any kind of injection style attack. This was simply just being smart about, hey, what if I do this to the API? What if I do that to the API? Then what happens? So my last example is from e-commerce. This was by a security researcher who was looking for problems with Coinbase. So Coinbase had a new feature that allowed you, it was related to how you sold crypto that you own. And he was looking at the API calls, and he sees the cryptocurrency symbol in the sell API. And he says to himself, what if I change that symbol to something I don't own? In this case, he didn't own Bitcoin. He changed that sell API to specify Bitcoin, and the API didn't validate whether or not he even owned Bitcoin, and it allowed him to sell Bitcoin even though he didn't own it. Because the developers are thinking that someone is only going to be using a web app. Someone is only going to be using the mobile app, and they're planning on that being the way that they prevent people from doing this. But you, like I said, you can right-click in your browser, go to inspect, click on network, and then you can see your API calls. You can copy-paste them into Postman. You can copy-paste them into command line utilities, and you can explore what you can do with the API. So what should we do about this? So to deal with this situation, you need several different options, which we're providing. The first one is discovery. It's pretty hard to secure something that you don't know about, that you have no visibility into. So that's kind of the first step. Get visibility into the API. Let us do classification. So that means we find where there's sensitive data. There's social security number, there's email addresses. We'll automatically identify that within the API. Step 2 is what we call posture management. In my very first example, we had an example of an API that had no authentication and provided a lot of sensitive data. This is the type of thing that we find all the time with our posture management tool. It will identify those misconfigurations. It'll identify compliance issues, gaps in best practices, things like that. Step 3 is runtime protection. This is where we're leveraging ML to learn what normal looks like for an API so that when not normal happens, we can let you know about it. If you were the person that had to figure out where does this API have a vulnerability, it's not really obvious to you. There's a lot of trial and error, trial and error, trial and error. Like if you're a developer, you could be smart about it, but still you have a lot of work to do. All that trial and error going on shows up as a red flag to us saying, hey, this person, this Tony person is not acting like a normal user. He's acting like, I don't know what he's trying to do. Let's stop him before he actually finds a vulnerability and starts exploiting it. So it's a way to find that recon action that's going on by using ML. And finally, number 4 on our list here is active testing. So rather than waiting till something gets deployed, the whole term is shift left. Let's shift left and look for these types of issues in the development process, right? So we have a tool that automates that testing, acts a lot like a human, looks for the OWASP API top 10, looks for BOLAs, looks for issues with authentication, and can tell you, hey, you have a problem here, here, and here. We're going to mark these as critical, and it's up to you. You could say, hey, if it finds something critical, you can actually stop the build, force the developer to solve that issue, and then retest on the new code. So 4 things: discovery, posture management, runtime, and testing. So where do we get our data? We get our data out of band. We're not another inline tool. We operate totally out of band. We get a copy of traffic from something that sees it decrypted, like a proxy, like an API gateway, a lot of F5s out there. So we get the data passively from these sources, and then we integrate with, as I mentioned, most recently, CI/CD integrations to do the testing, and we integrate with whatever kind of workflow tool you have, like it could be Splunk, it could be a SIM, it could be a ServiceNow, a Jira, to say, hey, we found something, an attacker found something, it needs to go get corrected, so we can automate that process. And that's what I have for you today. I'll be in the booth area. If anybody has specific questions about API security, I'd be happy to take your questions, and I thank you.